A $13 billion warship, 5,000 sailors aboard, 80 combat aircraft ready to fly, and somewhere in the middle of the Pacific, 1,000 miles from the nearest port, something breaks. No garage, no tow truck, no shipyard within reach. The most powerful warship ever built by human hands cannot just pull over. So what actually happens? The answer involves machine shops buried deep inside the hull, helicopters flying in at midnight, and a chain of decisions that goes all the way to the top of the US Navy. And the more you learn about how this works, the more you'll realize that these men and women in uniform have thought of everything. Today, we're breaking down exactly what the US Navy does when something goes wrong with the engines on one of its nuclear-powered aircraft carriers. Right in the middle of the ocean, mid-deployment, with no base nearby. This is a story about engineering, grit, and the kind of problem solving that only America's finest are capable of.
Do what you would do if it was wrong. Roll call, 502.
What you're actually dealing with. First, you have to understand the machine itself. A Nimitz-class aircraft carrier stretches over 1,092 feet from bow to stern. That's longer than 3 football fields laid end to end. When fully loaded, it weighs more than 100,000 tons. Under that massive hull, there's 2A, 4W nuclear reactors. Each one generates enough heat and steam to power a small city. Together, they push 260,000 shaft horsepower through 4 propeller shafts. Those propellers, each one 25 feet across and weighing 66,000 pounds, are what drives this floating fortress through the water at over 30 knots. And when we talk about the newer Gerald R. Ford class, the ones that actually cost $13 billion, the power plant is even more advanced. The Ford class uses 2A and 1B reactors. These are at least 25% more powerful than the older A4W models. The Ford class also triples the electrical output compared to the Nimitz class. That's not just for propulsion, it powers the electromagnetic launch system that fires jets off the deck. These nuclear reactors can run for over 20 years without needing to refuel. The ships are designed to last 50 years. The Ford class is expected to remain in service until the year 2105. So right off the bat, the propulsion system on a U.S. nuclear carrier is one of the most reliable pieces of machinery ever built. The U.S. Navy has logged over 6,200 reactor years of operation across more than 526 reactor cores, with 0 radiological accidents, not one. But nothing is perfect forever, and the ocean has a way of testing everything. The first line of defense, the ship itself. Here's something most people don't realize. An aircraft carrier isn't just a warship. It's a fully equipped repair facility that happened to float. Deep inside the hull of every carrier, there are machine shops, welding bays, hydraulic repair stations, pipe shops, electronic labs, and fabrication rooms. The crew doesn't just operate this ship. They can manufacture replacement parts from raw material stock if they have to. These aren't small workshops, either. They are serious industrial-grade spaces packed with lathes, vertical machining centers, horizontal machining centers, and precision tools. Navy machinery repairmen, that's an official rating, are trained to fabricate and fix parts for the machinery and the equipment across every inch of the ship. Sailors called aviation structural mechanics handle aircraft systems, including hydraulic pumps, auxiliary power systems, landing gear, and engine-related components. The green jersey crews on the flight deck are responsible for inspecting every aircraft before and after every single flight, engine condition included. Every jet gets checked every time without exception. This around-the-clock maintenance culture is what's keeping the ships running day in and day out. The philosophy is simple. Don't wait for something to break badly. Fix it before it gets worse. But there are limits to what the ship's own crew can handle. And when those limits are reached, that's when the second layer kicks in. The real-world test, USS George H.W. Bush. Before we go further, please take a second to like this video and hit that subscribe button. Over 98% of people watching right now have never subscribed. It costs you nothing, but it means everything to us. Now back to the story. In August of 2022, something went wrong aboard the USS George H.W. Bush, a Nimitz-class carrier deployed to the waters of the U.S. European Command. One of its FA-18E Super Hornets, assigned to Strike Fighter Squadron 136, caught fire in flight. When the pilot brought the jet back aboard and the damage was assessed, the news wasn't good. The starboard engine had taken serious heat and fire damage. The damage covered the 68R door skin, vent screens, structural formers, the S11 skin, and the entire starboard engine bay, along with all the hardware connected to it. Under normal rules, that level of damage meant one thing: crane the jet off the carrier, load it onto another ship, and send it to a shore-based repair facility. That's how it had always been done. But the Navy decided to try something different. Engineers conducted a full assessment. They got on the phone with multiple fleet readiness centers, the Navy's network of shore-based aviation support commands, and after careful review, they concluded that a repair could be attempted directly aboard the ship. Arrangements were made to try to fly technical experts in by aircraft right to the carrier deck. In the middle of deployment, tools and parts were flown in as well. 33 days later, on January 9th, 2023, the repair was complete. The jet was back in service. The Air Wing commander, Captain Thomas Bodine, called it a resounding success. He said our ability to maintain and repair our aircraft while underway is a critical warfighting competency. It was the first time this specific type of engine bay repair had ever been done at sea, and the Navy made it happen without bringing the ship home. That's what American military ingenuity looks like. The chain of support, nobody fights alone. Now let's talk about the bigger picture, because a carrier never sails alone. Every U.S. aircraft carrier deploys as part of a carrier strike group. That group typically includes the carrier itself, at least one guided missile cruiser, a destroyer squadron with 2 or more destroyers, a carrier air wing of 65 to 70 aircraft, and critically, at least one logistics and supply ship. That supply ship is the unsung hero of every carrier deployment. The concept is called UNREP, underway replenishment. It means transferring supplies from one ship to another while both ships are moving at sea. No port, no stopping, just 2 ships running parallel, connected by cables and hoses. Through UNREP, carriers receive fuel for their aircraft, ammunition, food, and most importantly, for our story, spare parts. Critical components needed for engine or mechanical repairs can be loaded into supply ships at a base, sailed out to the strike group's location, and transferred across while the carriers keep moving. The U.S. Navy operates supply class ships. Names like USNS Supply, USNS Rainier, USNS Arctic, and USNS Bridge. These ships have been described as floating stores and ammunition depots all in one. They steam alongside the carrier at speed, ready to hand off whatever is needed. Even skilled technical experts can be delivered this way, flown in by helicopter from the supply ship or directly from a nearby shore base. This is America's single greatest naval logistical advantage, the ability to keep a carrier strike group at sea indefinitely without ever returning to port. It's not just a capability, it's a weapon. When it's nuclear plant itself. Now here's the question some of you are probably asking. What if the problem isn't the aircraft engines? What if it's the ship's own nuclear propulsion plant? This is where things get extremely serious and extremely controlled. The U.S. Navy nuclear propulsion program is managed under what's called the Naval Nuclear Propulsion Program. Every major technical decision, design, maintenance, operations, repairs, is made by a special headquarters staff. These are the best nuclear engineers in the country. Naval Reactors, as it's known, doesn't just oversee the program, it controls it completely. Here's the good news for the Navy. Both the Nimitz class and the Ford class carry 2 reactors in separate compartments. If one reactor has a problem, the ship can continue operating on the other one. That means the carrier doesn't stop dead in the water. It reduces speed and capability, but it keeps moving. It keeps the mission going. And if the problem requires a full shore base fixed, there is only one shipyard in the entire United States capable of handling it: Newport News Shipbuilding in Virginia. The maintenance culture that prevents the crisis. Here's the part that most people never think about. The best engine repair at sea is the one that never has to happen. The U.S. Navy entire maintenance philosophy is built around prevention. Carriers go through multiple scheduled maintenance cycles across their service life. Not just one big overhaul, but a series of planned availability periods built directly into the deployment schedule. Before every deployment, the ship's propulsion systems, turbine shafts, catapult systems, and all major equipment are inspected and serviced. The USS Dwight D. Eisenhower, known as Ike, just completed a significant maintenance availability in 2026. Work included inspecting engine turbine shafts and aircraft catapult launch systems. The Navy confirmed that the early completion of this work maximizes a ship's mission readiness and extends the lifespan of the vessel. Aboard ships during deployments, maintenance is a 24-hour operation. There is no day off. There is no shift that doesn't check something. Aircraft are inspected before and after every single flight. Turnaround inspections ensure that jets can be refueled, rearmed, and returned to a duty in tight time windows. One of the biggest threats to jet engine aboard a carrier isn't mechanical failure. It's foreign object damage. The smallest bolt, screw, or piece of debris on the flight deck can be sucked into a jet engine at tremendous speed and destroy it from the inside out. The entire crew is trained to treat the flight deck as a zero-tolerance zone for loose objects. That culture, that constant vigilance prevents hundreds of potential engine failures before they ever start. What the crew doesn't say out loud. Here's something you won't read in a press release. When something breaks on a carrier in the middle of the ocean, the first thing that happens is not panic. It's not a dramatic emergency broadcast. It's quiet, focused problem solving by people who have trained for exactly this scenario. The carrier's maintenance officers and engineering department have decision trees for almost every failure scenario imaginable. They know at what point they can fix it aboard ship. They know when to call for parts. They know when to request fly-in technical experts, and they know when the situation requires redirecting the ship to a port. The crew of a nuclear carrier includes around 5,000 sailors when a full air wing is aboard. Within that crew, there are hundreds of engineers, technicians, mechanics, and specialists. People who know the ship the way a doctor knows the human body. They don't just work on the carrier, they live inside it. They feel its rhythms. They know when something sounds different before any alarm goes off. That human element, that depth of experience and training, is as much a part of the repair system as any machine shop or supply chain. The Navy has invested decades in building that expertise, and it shows every time something goes wrong 300 miles from shore, and the crew handles it without missing a beat. The bigger picture. Let's zoom out for a second. The U.S. Navy currently operates 11 nuclear-powered aircraft carriers. No other country in the world comes close to matching that number. The next closest nation operates 2. These carriers represent decades of investment, engineering expertise, and national commitment to keeping this country safe. A single carrier strike group, one carrier, its escorts, and its air wing carries enough firepower to rival the air force of entire nations. And the system built to keep that carrier running, the onboard repair teams, the UNREP supply network, the Naval Reactor's oversight, the shore-based specialists on standby, that system is a weapon in itself. When you see one of these ships deploying, know this. There is not a single scenario the U.S. Navy hasn't prepared for. There is not a breakdown they haven't thought through, not a repair they haven't drilled. The men and women keep these ships running in the middle of the ocean, often without recognition, often without sleep, are some of the most skilled technical professionals in the world. They don't get movies made about them, but they are the reason those $13 billion ships never stop moving. So the next time you see footage of carriers launching jets in the middle of the ocean, or read a headline about a carrier responding to a crisis on the other side of the world, you'll know the full story. It doesn't just happen. Every single day, thousands of sailors are doing the quiet, hard work that makes it possible. That's what makes the U.S. Navy the most capable naval force on Earth. And that's what makes the people serving aboard these ships worth every ounce of respect we can give them. If this video added something to your day, hit the like button and subscribe. It keeps this kind of content coming. We'll see you in the next one.